David asked me to talk. My first reaction was, well, okay, not so long ago. And I thought, you must be gluttons for punishment. But when I went and looked at my records, it was actually 3 years ago. So time goes by. But for the diehards who were there then, I apologise. I'm going to probably cover a lot of the same issues. That's because the basic principles don't change. There's maybe some more insights. We're all learning on this process. So as we get more into it, we get a clearer understanding. But there's still a long way to go. This is just a brief outline of all the things to cover. Firstly, the first thing to consider is, do you need to build a new home, or is it sufficient to renovate? There's a large cost involved. It's going to upset your lifestyle for a while. And will it be a better sustainable outcome at the end? Building and developing isn't really sustainable. We create hacks, and the industry's been geared primarily to minimise those impacts. That's the way we do our statement of environmental effects. They're always looking at what the minimum impacts will be, or how we can minimise those impacts. We have to sort of change that concept. It may be better just to do a retrofit. You may be able to modify your house and just make it more sustainable without going to a large expense. There's a well-documented project in Melbourne completed in the last couple of years where they actually slightly reduced the area of the house, but they modified it so that it worked much better and it enhanced the sustainability in the process. So you can do it in other ways. So I'll cover the design and construction process a bit. Site and location is obviously crucial in terms of how you design a home that's going to work well with the environment. The size and layout can have a huge impact. Future proofing, we build our homes for probably a minimum 50-year time span. If we do it well, they'll last much longer. So you're talking 2 or 3 generations are going to occupy that building. So it's quite crucial that we do get it right and we make it work long into the future. I'll touch a bit on thermal comfort. That's an area I do specialise in a bit. Material selection and minimising waste. Energy and water efficiency is very important, but I'm not going to go into that because it's such a broad topic, and we have had other talks on. And landscaping, how to incorporate that, because sometimes that's something that is a bit overlooked. As I go through, I may skim over some things, so if there's something you want to know a bit more detail about, just feel free to stop me. One thing that I guess is constantly changing is our understanding of what sustainability is and how we can do it. And I did mention, that primarily our focus has been on minimising the negative impacts, and we should be really aiming to achieve positive impacts. How can we do a development that actually has a positive outcome? The difficulty with that is the more we get into it, the more complex it is. There has been a focus in the past to focus on the technology of it, putting solar panels on or making the house more, better insulated or whatever. But it's a much more complex situation than that. It's the occupants in the house, how they use the house, it's their social situation. You can make a house a lot more sustainable, but you could be in a very unsustainable situation where you live. You might have to drive a long way to get to work. And so there's a whole lot of other factors that can impact on how sustainable your living can be. You'll see down the bottom there's even things like the economic system, which I find that is a real challenge in my practice, is finding designs and doing a building that's affordable for people. In Sydney, renovations are very expensive, and the challenge is to do that in an affordable way, and so that the client doesn't end up with an unsustainable financial situation. It's crucial that all these things are in balance. In terms of positive impacts, we can certainly have a positive carbon output by putting on plenty of PV panels and reducing our energy use. But there's more positive impacts we can have on the social side. If we take a house that's cold and unhealthy and turn it into a house that's light-filled, well insulated and a lot healthier, then there's a positive impact on the life of those occupants. And that has a flow-on effect in the society in terms of reduced health costs, higher productivity, a whole range of issues. And we can also have a positive impact in terms of increased biodiversity if we're smart. We can increase the plants and the opportunities for wildlife and animals and just life in the broader sense being more, because we're creating a healthy environment, it'll prosper more. So you can see from that it is quite a complex challenge. Where to begin? If you're a homeowner yourself, doing your own research is most important, so you understand. So when you talk to people, you've got a good grasp of what the issues are. Unfortunately, a lot of designers, builders may not be as educated as you would hope in these issues. And there's plenty of places you can do that. ATA is a good resource. There's the magazines they put out, the website, you can do searches on that for back issues. There's the yourhome.gov.au, a federal government initiative, which has lots of really good information on the principles of renovating and designing a home. I'll give you some further references later. One crucial thing which Darren, who spoke last, or the month before last, who's a builder and designer, is that's crucial for him is that you write a brief. You set out what you really want to achieve. And that may take a bit of time, and it may not necessarily be a physical thing like I want 3 bedrooms and a big open plan living room. It might be more aspirational things. I want to improve comfort, I want to have a nice atmosphere, more light, or I just want to improve the value of my property. If you work out what your objectives are, it makes it much easier for the design and building team to achieve that if it's all quite clear. And building a team is an essential item. Traditionally, the construction industry is run on a more adversarial type of arrangement, which is not ideal. If you really want a sustainable outcome, you've got to break through that. And the way to do that is to create an open, honest atmosphere, be clear about what you want and engage everyone. You can select a designer, and there's plenty of opportunities to do that. We've mentioned the Speed Data Sustainable Designer. The Sanctuary and ATA websites have listings where you can search for sustainable designers. Your Future Home is another one that has listings. So there's opportunities out there to speak and get a grasp of someone you're going to be able to work with. The crucial thing with all of these, the team you put together, it's a long process. It may be 12 months, but sometimes it could be 2 or 3 years by the time you talk to someone before you have a finished product. So you've got to find someone that you can work with. They're going to get involved in your life in a fairly serious way. So it's quite crucial that you feel comfortable with them. And I'm finding that getting the builder involved early in the process is very crucial to achieving this collaborative approach. And I'm tending to do that prior to getting council approval. Once we have a design nutted out, I then go and get some indicative prices from builders. And not only, it's a good basis to check whether you're on budget, but it enables your client to meet builders and engage with them and get some idea of who they could work with. And then you can get the builder to collaborate on the design development and inform you on what's going to be the most affordable or effective way for him to build. And you can instill in him, while you're going through that process, the sustainable outcomes you want to achieve. The same with the engineers. You've got to make sure that they're on board, that they don't just churn out what they normally do. You want to make sure that they understand what your end goals are. And A thermal comfort assessor, I think, is an important part of the team. Often overlooked. I don't know, are people familiar with the concept of basics, which is the state government compliance requirement? That has it's to do with energy and water saving. It has a thermal comfort component. You can do an online tick the box, do it yourself process, but that's fairly basic for basics. But if you really want to optimise your thermal comfort performance, you should get an assessor on board, and you make sure that they can get engaged. They're often engaged just to achieve compliance. You want to make sure that you're wanting to go beyond compliance. And just a note there about making sure things are included before you commit. It's much harder to change things when you're halfway through the process. We talked before about how crucial site is. If you don't have a site yet, well, certainly these sort of things are worth considering when you're looking at sites, whether it's a interurban situation, you know, you're going to have challenges there. Maybe acoustics might be a real issue in that environment. Overshadowing certainly could be. The local climate, microclimate, where do the breezes come from? Those sort of things. Where does the driving rain come from? If the water cycle is probably more crucial on larger rural, semi-rural situations, but it's still worth considering. And again, as I mentioned with biodiversity, there's House Sears, good example, which participate in Sustainable House Day, but they've introduced a wider setback than normal down the side of the house, and they've put native gardens down there. They're right next to the national park and the harbour, and so they've created a sort of riparian travel zone for animals down through there. So you can incorporate those sort of things. This is just to give you an idea of what a site analysis might be done by an architect, just to understand. It's fairly rudimentary. They haven't considered wind and maybe other things, but it gives you an idea of the sort of thing you need to think about before you start designing. There's lots of good climatic data available on the Bureau of Meteorology website. So for your specific site, you know, mean daily temperatures, even relative humidity, and you can see even the number of cloudy days and clear days, which can be useful in terms of thinking about solar design. And from that you can actually download these wind roses, which are quite interesting. This is for Sydney, and this one on the left is 3 p.m. in January. So you can see all of the wind. So it's on a percentage basis, so the longer the line, the more wind from that direction, and the deeper the colour, the higher the speed. So in summer afternoon, all of the winds coming from the northeast or the east. This is the July, 3 p.m, it's totally reversed. So straight away, you can see from that you've got a concept of how you should open your house and how you should be able to be shutting it down. So it's a matter of getting familiar with your site in that sort of way. Size and layout. We, as Australians, we have the dubious reputation of having now the largest houses in the world, and that's really not sustainable. And so we need to be smarter in that regard. One way to do it is we can make houses feel bigger than they really are. We can make them more flexible, and that also makes them more suitable for the future, because families change, our situations change. The obvious thing, a smaller footprint means you use less materials, there's less impacts, you end up using less energy over time, and you end up with more yard, hopefully, which is becoming more crucial. There has been a tendency to build big boxes which, you know, expand right to the maximum setbacks, but whether that's really a good approach. But one thing to keep in mind in terms of solar planning is you need to try and optimise your northern orientation. There's a few items, future proofing, as I've already mentioned. The lifespan of the house will be for a while. Optimising solar planning. durable materials. And going back to the size thing, it can be a matter of quality over quantity. You might build less at better quality so it lasts longer. You might end up spending the same money, but you might get better value out of it. There's guidelines on livable housing, which are making houses more accessible for people in terms of general bathrooms, and there's a whole set of guidelines in there for all the service areas, and there's different grades where you can actually get your plans rated for their accessibility. There's a push that all housing in Australia should be adopting these guidelines. We've got an ageing population. It's silly for us to be building new houses that we can't actually get around easily in. As I mentioned, I'm not really going to talk about energy and water systems, but certainly isolating yourself from changes in power bills and those sort of things would help. Changing technology is a bit of an unknown space. I think David was hoping I might cover things like sort of more sophisticated technology, monitoring systems, and your automated systems for homes. I feel that that's an individual choice. I don't think it's really necessary to make a home sustainable. The technology is changing all the time. It's easy to plug these things in, especially now we're virtually going wireless with everything. The one things I would think about, you probably want to allocate some space for a central hub, so you can have, you know, your major technologies there, your modem and those sort of things, and maybe even space for battery storage for your PV system, because that will become an important thing in the future. And if you're going up with several stories, provision to get services up and down is one thing to keep in mind. But it's certainly, you know, there's a lot of stuff out there, and there's lots of apps you can use to control your house. I feel personally it's much better to have the occupant control the house themselves, so they're more in touch with their environment. That may not necessarily fit with our busy lifestyles, and it may be good to have the flexibility to preset your air conditioning or turn it off from work or whatever. But I think it's more important that you get the design of the house right. From the solar planning point of view, it's much harder to change the physical construction of the house if you don't get that right initially. It's that over the life of the home, over 50 or 60 years, the technology is going to change a hell of a lot, and you can always plug and play with that. So it's crucial you get the layout and the construction right to begin with. Transport's important in terms of that can be a big contributor to emissions. Once you make your house more efficient, that probably might become where most of your carbon footprint might be. So if you're looking for a site, consideration of transport and access to transport is one thing to keep in mind. You have to excuse me, I'm on the back end of a cold, so it's starting to catch with me. So if you get the building form right, it's crucial that you get the thermal comfort performance right. And so these are the things that can impact on that: the orientation, the zoning and the volume, how the house is arranged, the planning of it, insulation in the walls, the thermal mass, windows, how you shade the windows of the house, and ventilation, how you get fresh air through, or how you stop air escaping or cold or hot air coming in. And just going through those in a bit more detail. How do we actually understand thermal comfort? These are the factors that impact on us personally that will impact on our thermal comfort. So we need an air temperature that's at a suitable range, and that varies for individuals, and it varies depending on what you're doing. So it can vary depending on all these factors. So your activity, your clothing, So we can dress for the climate, like these guys have done there. But if you're in a gym, you're going to be generating a lot more heat. If you're putting a gym inside your home, you might want to consider how you're going to ventilate that space. You might want a small air conditioner in there to treat that heat load. Radiant temperature is the temperature given off by surfaces. So I've showed a picture there of a basement with stone. You probably know this when you go into, say, an old double brick home in summer, and you can feel how cool it is. It's a term called coolth, and it's the walls are absorbing the heat out of the air. And the trick with thermal mass to do is to help stabilise the air temperature through the radiant process. And air velocity, the amount of breeze you get through fans or opening windows. You all know what it's like when you're sweating and you open the car window, or you open you get the evaporative cooling effect. When the air passes over your skin, it evaporates the sweat and you feel more comfortable. Sydney is a challenge in late summer with our humidity, and it can be difficult to design that in without having to go to air conditioning at some times, but it's something to consider. Orientation and zoning, this is just a small addition. It's just to show you north is that way. So the extension has been extended to optimise the northern orientation, with most of the glazing on the north side, some small windows on the southern side to get good cross ventilation. Normally the tendency might be to come out this way. It's what the council suggested. But to give you, a lot of people like having that direct look into the yard, but you're really knocking out all your winter sun. You create this space here which becomes sheltered from the winds and still attracts a lot of sun, and you still get outlook into the yard. Smaller windows on the west, you might want to enlarge those if you've got if you have a view, and you tend to put your service rooms on the southern side. So they're not as crucial in terms of getting the winter sun. Insulation, I won't go into that in much detail. There's a whole range of them. Obviously, it's something during construction you want to get as much in as possible. But if you have a thermal comfort assessor on board and he models your house, he'll be able to tell you what the optimum level is for the different surfaces. There's good products. Some of the foam products are really efficient, but they're quite expensive. These products are more affordable. Polyester has some advantage because you get a high recycled contents. You get some materials such as straw bales, which are in themselves insulative, and that can be really good. AAC, for those who don't know, is Hebel blocks, aero autoclave concrete. One thing to keep in mind is what a challenge now, if we make our houses a lot more insulated and better sealed, we then can run the risk of condensation in the roofs and so forth. So you have to consider being able to ventilate your roof, and that normally is a requirement in the winter time, and so it's contradicts what you're trying to do in terms of seal the building and keep it in, keep the cold out. So there's things to be aware of there, and using breathable membranes in the roof and in the walls allow the walls to breathe, or using actual building materials such as straw bale with clay renders or mud bricks are materials that naturally breathe and they won't hold the moisture in. You'll have to tell me how I'm going for time-wise. As I mentioned, thermal mass is crucial in terms of helping to stabilise the temperatures. There's a whole range of them there. The crucial thing I would stress that it needs to be in the interior. Traditionally we build brick veneers, we put all our thermal mass on the outside, it heats up, it cools down, and we don't get any benefit of it. The insulation's on the inside. So you can reverse that and put the insulation on the outside, brick on the inside. I feel that probably the most effective way for our climate here is you do lightweight external walls, highly insulated, and make your internal walls masonry or thermal mass. You can do it with a slab if you've got good orientation, but yes, it's not very effective hanging on the outside of the building. Masonry is durable on the outside, which you face brick, and there's one reason traditionally construction's gone that way, but from a thermal point of view it's not very good. It is a challenge with these type of materials, which are really good from other sustainability point of view. They're low energy, renewable products, they have a nice feel, but they have poor insulation value. They have good thermal mass. So the challenge there is how do you get the insulation on the outside? And that is sort of limiting their use a bit, unfortunately. Glazing and windows are your weak point. That's where you're going to lose all your heat or gain all your heat. There's now a lot of use of low emissivity glass, which helps stopping heat coming in, and so it's very effective to use on, say, the east and western windows. Double glazing is very effective to minimise your heat loss. It can slow down your heat gain, but also curtains with pelmets will do the same. They'll be a good heavy curtain with a pelmet will be as effective as double glazing. It'll probably cost the same as well. So it's more a matter of what your choices are. Window frames, there's quite a choice there, and they all vary thermally. The metals, aluminium and steel, because they're good conductors, they're going to gain a lot of heat or lose a lot of heat. There's now thermal break aluminium windows where the frame's split into two with an insulated barrier between, which slows that down. That's quite expensive. Steel have become quite trendy. And steel windows over there, they were very popular, say back in the 30s, but they perform very poorly. In fact, there's none of them actually officially rated under the window energy rating scheme as yet, but they are being used. Timber works very well thermally, it's a poor conductor, but it has durability issues. You have to keep painting it or sealing it. So they developed the composite, which has aluminium, good durable aluminium on the outside and timber on the inside. And that gives you a thermal performance somewhere between the two. And the cost is somewhere between the two as well. Newer on the market is PVC. Generally they come from overseas, from European or American, so they're very good quality in terms of the air infiltration. They seal very well, they're durable. There are some questions about the manufacture of the PVC and the toxins that are created in that process, but they do as a window, thermally they do very well. Style-wise, they're not everyone's cup of tea. There is a window energy rating scheme similar to the appliance scheme, and you can get a rating for heating or cooling depending on what your need is. So if you have a west-facing window that's getting a lot of afternoon summer sun, you probably want a good cooling score. If you've got a big picture window looking down over the harbour facing south, you're going to lose a lot of heat out that window, you probably want a good heating score. The performance values they look at are what's called the U value, which is the heat transmittance. It's the inverse of the R value, which is the heat transmittance for the insulation. And so your normal windows is about 7 if you get a decent window, 4 if you get a really good double glazed window, it's under 3, maybe 2.5. The other important one is the solar heat gain coefficient, and that's a measure of the amount of solar heat that's transmitted, direct solar heat once the sun's on it, that's transmitted through the window. Approximately it's like 0.7 it's transmitting about 70%. It's not correct, but it gives you some idea. So a good one, a bit lower than 0.4, is transmitting less than 40%. So that's where the low E glass will come in. Or if you get double glazing and you have low E coating on one of the panes of double glazing, you'll get a really low U value and a low SHGC. Shading is important to make for sun control. Eaves are the traditional way, although style-wise there's been a tendency to lose eaves. We've also forgotten about the good Aussie veranda, and not only as somewhere to help shade the house, but as an extension of the living room. This one here is a holiday house on the north coast, but yeah, it just connects better to the yard, and the people who use it sit out there a lot. Pergolas are good. Adjustable, operable shading is important, especially the in-between periods where, with the way the climate's going, we can get a 30-plus day in October. And if your eaves is designed for the middle of summer, you're going to get a lot of sun coming in. So if you've got adjustable blinds, awnings, even shade cloth that you can roll out, that gives you a bit more flexibility. Pergolas and growing trees and vines, create a nice space, and can really help with the shading. And I've got a pergola on my place which has grapes on it, and you get to eat them as well. So ventilation's crucial. Obviously, looking at understanding where your breezes are coming from, getting the plan form right, keeping it. Remember that one earlier, it was long and narrow, so you don't have a room that's landlocked or stopped by another room. Ideally, each room should have windows on at least two sides. The different types of windows. Louver windows give you the most ventilation. Casements are quite good, the type that open like a door, because they create a positive and a negative pressure, and they give you the most ventilation for open area. Stack effect ventilation is like a chimney, and it's using the aspect that you can get hot air to rise and exit at a high point, and that'll draw more cool air in, which is useful. Often up through a stairwell is a good spot to do that. Sealing and infiltration, I'll go into that in a little more detail. If you really want to be at the cutting edge, Passive House is a German initiative. They're doing very efficient, very well sealed buildings, highly insulated, and they're geared to use a minimum amount of heating and cooling. There's some now being built in Victoria. They're only just started in Australia, but they do have a certification system. They're that well sealed that you have to have a mechanical ventilation system to bring fresh air in. It doesn't stop you opening the doors and windows when the conditions are right, but if it's getting too hot or cold, you close it down and you get the air pumped in, and it can be treated, can be heated or cooled. I don't think you probably need to go to that level for our climate here. Maybe Canberra or in the alpine regions. I think we can get quite comfortable houses without that. Infiltration is something as an industry we're only really starting to come to grips with. There's requirements in the BCA, which is the building code, for sealing and minimising infiltration, but unfortunately, my experience, the industry and certifiers aren't really aware of this, and it's not really being implemented. So I think it's something you should raise with your designer and your builder and make sure that they are aware of them. You should try and avoid ceiling penetrations. If you're building a house that's well sealed and well insulated, and then you cut all these holes in the ceiling, once you cut a hole, you've got to pull the insulation back, and they become like little chimneys, especially the halogens. They heat up, hot air rises, it sucks more air out of the room. If you've got 12 of those downlights in a room, your insulation becomes like Swiss cheese. So if you can avoid using them, you can get covers to put on them, and that allows you to bring the insulation closer, but it can affect their performance. It can reduce the lamp life. I think it's better to try and look at other lighting alternatives, looking at spotlights, wall lights, pendants, strip lights, other ways or even the traditional oyster fitting. You can now get quite good LED oyster fittings. Ceiling doors and windows. Exhaust fans can be a weak point. Traditionally, we've often just dumped the air into the ceiling. Now those ceilings are full of insulation. The condensation goes into the insulation. The fiberglass, the polyester absorb the moisture, and that reduces their performance. You should try and get all that damp air right out. Take it out through the roof, but you should have a damper on it, so that when it's not running, your warm air isn't just going up the chimney, basically. The other thing is making sure that the builders and plasterers do a good job and give you good tight ceilings of linings. They develop skirtings and architraves traditionally to hide the gaps, and you can, especially in older houses, you can maybe feel the draft coming through under your skirting where the floorboards have dropped or whatever. So checking those sort of things. A good way to check for drafts like that is to just get some incense and move it around, and if the smoke starts moving in a certain direction, you can see which way the drafts are coming. And that's a crucial part of renovations. You might do an extension which is all well insulated and very well sealed, but the old part of the house is still leaking like a sieve. And so it's a matter of looking at that. It can be a challenge, old floors move and so forth, but it can do a lot to improve even the old wall vents, which were originally put in because of gas lighting, so that there was some fresh air coming in, so people didn't get poisoned. They should be sealed up, so you're not just losing all your warm air. This is in old brick homes. Okay. Thermal comfort, as I mentioned, I don't know if people are familiar with the process, but the assessor will create a computer model, algorithmic model of your house, and do an analysis of what the heating and cooling demands would be. And he can help you to optimise your design. He can create temperature graphs of individual rooms. This is what a house under normal construction would be, and this is what we were trying to get to, where you can get your temperature in a steady comfort range. And it can be done, but it can take a bit of effort. But as I said, a lot of assessors aren't used to going to this sort of detail, so you want to ask them up front, can you do a detailed analysis? Because I don't want to just meet basics compliance. I want to make sure I get a house that's going to be a 7-star or an 8-star house. It's usually done for new houses, not that often done for renovations, but you can do it. It'll tend to show that the old part of the house is performing really badly. But then it can show you what's going to be the most cost-effective strategies for improving your old house. They can change things, change the type of window, change the insulation, even change the roof colour, and you can see straight away what the impact's going to be. So it can be used as a design tool to help you make decisions about materials, insulation levels, types of glazing, or types of shading. How much, do you have enough shading on the west? What if we extend it another metre? Is that going to improve the performance significantly to warrant the additional cost. This is a case study of what can be done. This is a house, it's on a site which is long, it's running north-south, so this is looking from the southwest. So the house, the long sides of the house are facing east and west, so it's not ideal orientation, but the design did have a lot of large glass on the north facade, so they were collecting lots of sun. Initially, it did have an awning over this, and it had shading devices on these windows, but when they built it, they felt they didn't want to use that. The clients were European, and they were very conscious of the much higher stringency that occurs in construction in Europe, and they were wanting to get to that level. And so that was done through using the UPVC windows, very high quality performance. Again, the U value would have been under 3, probably about 2.5, and the solar heat gain coefficient again would have been about 3, I think. Reverse concrete construction, so the walls of concrete construction, a prefabricated system, and then a thick board of extruded polystyrene is put on the outside. But they were careful that the layer of insulation was continuous, that it didn't just go up at the wall and then there was a junction and then it went into the roof, that it actually went up and wrapped over and went onto the roof. And so they were able to get quite a high performance with that high level of construction, which isn't cheap, but they deleted the shading device and still achieved. There were some other changes which resulted in that difference through different floor surfaces. They used a bit more tiles. They had concrete slabs. Concrete slab is good thermal mass. If you put a carpet on it, it insulates it, so you're not getting good heat transfer into that thermal mass. But if you put tiles on or you leave it as bare concrete, you get much better performance. Okay, I'll just go through these. There's a whole lot of sustainable materials, and I think you can read about them in Sanctuary and so forth. There's some new advances in concrete, mainly through, not promoting any particular company, but Boral have some new products available there. Durability is an important consideration. And again, for internal, where it's more a health concerns about pollutants and low VOCs, paints and materials. And there's lots of environmental certification products, so you can see whether the product you want to use has been tested for its environmental credentials, which can help you make choice. And the other thing to look at is waste minimisation, which has been getting a lot better, primarily because the landfill sites are recycling a lot more. Concrete and brick has been crushed up and used as road sub-base and aggregate in concrete, a lot of the timber and so forth. Asbestos and those sort of materials, you don't have much choice. They really need to be disposed of properly. But you can make choices if you do your research on what the recycled content is in the material, and even packaging, if they've thought about the packaging that the material comes in, because at least I saw one figure, about 10% of the waste on a building site is cardboard. And I'm sure there's a lot more in terms of plastic as well. Getting the contractor on board, another thing, you want to get him involved early in the process. A lot of builders want to just demolish. It's quicker, it's easier, mate. I don't want to have to bother. But if you can get them engaged in it, the other way, if you can do it yourself, if you can do a slow deconstruction rather than demolition and try and salvage as much materials, that can be a more affordable way to do it. That's just a concept of how to approach waste through asbestos is down here, managing the waste and eliminating or preventing pollution. Just some examples. Prefabrication is much more efficient, there's a lot less waste, and there's some really quite good quality prefabricated dwellings now available. I showed you that small extension earlier. This is just a simple sample. This wall has been set out to the board width. For affordability, it's just simple fibre cement with a batten over the top. But they've been spaced to, and the windows have been sized to suit the sheets. And so there should be minimal cutting. They might need to cut the length, but they might have enough, you know, to do some of the eaves with that. So it's just, that doesn't cost any extra, it's just being a bit smarter in how you lay it out. And just, again, as we're talking about deconstruction, avoiding adhesive, using mechanical fixings, and thinking about what things are going to wear out first. And this is an interesting fact. If you're not sure whether you're going to renovate or knock down and rebuild, a lot of the project home builders are selling the concept of knock down and rebuild because they can do it much more affordably. It's just the environmental cost is not really factored in. But you can just see the amount of waste that can be generated through that process. Incorporating food growing and biodiversity into design is something that needs to be considered. I don't think I need to go into much detail in that. And again, they're just some things to think about. Before you start on site, I think it's good to sit everyone down and talk about what you really want to achieve. As I said, basics, that's just to tick the box. You want to be going beyond that. Ensure that specification is a useful document, but residential builders aren't used to reading them. So again, at this meeting, you want to get them on board, including the subbies, and point out, even highlight in a different colour, the crucial things in the specification. Because their tendency is they'll just do what they've always done. And so you want to bring it to their attention. And that's why you've got to be on your guard. And as I said, insulation is, again, it's an area that the industry is still learning. And so you want to be on your feet and asking them questions and making sure they understand how those products are going to be installed and properly installed, especially in terms of dealing with the condensation issues. And operating the house. We get manuals for our cars. We spend a lot more on a house, but no one gives us any guidance on how we use it. And it's just something to think about. If you get involved early in the process, you probably won't need a manual. You'll probably be able to write the manual, hopefully. And there's just some references, useful things. Assessor for the thermal comfort. Assessors, Sustainable House Day, which the Solar Council runs, where sustainable houses are open. Archi Centre, where you can connect with an architect. The Your Home website, Your Future Home, and of course the ATA is always a useful resource. Thank you.